bit confused when I use power series. A power series is just a series, which means we're going to add our terms, and these are going to be powers. A Taylor polynomial is a power series. Okay? So if they ask for a power series and they mention Taylor, don't worry, it's exactly what we've been doing. So a Taylor and a Maclaurin are also power series. And then there's the geometric family, which is the one we're going to start with. And a power series, in other words, we're going to center this at 0. So we're going to find, and that would be like a Maclaurin. We're going to find this summation, but we're going to center it just at 0. So we're not translating it at all, shifting it. C's are constants. And when you get to the Taylor polynomial, we know that the constants have to do with the derivatives. That was just another way of finding a power series. So it's a series of powers. Okay, so these are powers. And I have a typo. This should be squared. This should be cubed. Sorry. You've seen this before. I used this before. Now, if we want to shift it a little bit, you can. You can just do a translation of A units over. You'll see what that means in a second if you've forgotten. Okay, there are 3 things that can happen with our power series. Well, I'll save this. I wouldn't take notes on that particularly. But when we get to some problems, yes. There are 3 things that can happen. This series will converge only when x equals a. If x is equal to a, what is this going to be? That's going to be 0. If you add up 0 an infinite number of times, you get 0. That converges. But it might not converge for any other value. So you might be thinking it diverges for everything. Well, if it's got an x in it, whenever it makes that 0, it will converge for just that single point. Or this might converge for everything, any x value. Or you might get an interval. And that's this. It kind of got cut off, but it's x minus a is less than r. So there's your radius of convergence. And we did some of these last night. Okay? It must be 1x minus a. You can't have 2x. If you get 2, you're going to have to factor it out and divide. Okay? Is that okay, Nick? So it's x minus a. They might ask you for the radius of convergence. The interval of convergence, that is going to be a little bit different. In this case, r is equal to 0. This radius is everything, so it's infinity. And this one is going to give me numbers adding in. You can solve it x. You want to be r units away from a. That's I like to do it geometrically. Yes. The radius is just how wide it is. We'll do problems. So if I say x minus 2 is less than 3, I'm going to center it at 2. And I'm going to go 3 units to the right, which is going to put me at 5, and 3 units to the left, which is putting me at negative 1. So my interval is negative 1 to 5. However, I must now look at the endpoints. That's just the interior. And how we determine this is the ratio test. It's always the ratio test. And if you've ever noticed, if you put the endpoints in the ratio test, you always get 1. Remember, when the ratio test gives you 1, we know nothing. You always have to check your endpoints. The geometric ones don't. But you can never hurt yourself by checking endpoints. Yeah, so I always recommend that. And that's what that says. The ratio test can be determined the radius of convergence in most cases. Everything I have. But the ratio test always fails at the endpoints. That's when the ratio test gives you 1. So that's why you put the endpoints back in the original series and see if that endpoint itself converges. You could try every number on the number line. You don't have to do the ratio test. You could do guess and check and say, okay, it converges here or it converges there. You could do that. That would take a little bit of time. Well, you could always do that. Now, before we do that, let me remind you of one power series in particular. I don't know why I don't have it here. But you remember this. 1 plus x squared plus x cubed plus x to the n. And you can say that's the summation of x to the n, where n starts with what value? 0. Really isn't going to be too important where it starts. It's where it ends up. What's special about that? It's a power series. It's true, but it's a special power series. How do you get from here to here? Multiply by x. How do you get from here to here? Multiply by x. This is geometric. Okay, so what's the ratio, the common ratio? X. And so this will converge provided the absolute value of x is less than 1. And so we can use the geometric series formula, which is S equals A over 1 minus R. So S equals, what's A? 1 over 1 minus X. So what I'm saying is that this is equal to 1 over 1 minus X, provided that my ratio, my X, is between 1 and negative 1. Because the common ratio, R, is less than 1. And that will never converge at the endpoints. The problem with it is if you integrate a geometric series, and you must check your endpoints. If you differentiate, you don't have to. Well, then how do you remember when you do and don't? So if you always check them, you're always safe. Okay? So if I put this on my graphing calculator, that's a rational function. There's a vertical asymptote at 1. But I get the same picture. Now, do you remember doing that, or do you want me to do it again? I think it's kind of cool. If I graph this in y1 and this in y2, I get the same picture. Only between 1 and negative 1. I think it's worth doing it again because now it's hopefully coming together. Well, that's my plan. So you're taking you're taking a rational function, and you are, I'm going to clear all that out. I'm going to graph 1 over 1 minus x. Okay, that's a rational function. I'm going to zoom at 4 because that usually gives me a nice window. And there it is. If I use my Inspire calculator, I could do it in color. Okay, now let me put this one in. And you know what? I could use a series, a sigma, because it does have it on there, but I don't care. It's 1 plus x squared. How many terms do you want? Plus x cubed. It is in the math menu, but I don't want to bother. Plus x to the 4th plus x to the 5th. Do you want degree 7 or 7 terms? Degree 7. The more you get, the better. But honestly, they converge very quickly. So when they use this in the biomedical field, they use about the first 3 terms. And yes, they do use Taylor series in the biomedical field. Okay, so I'm going to change this so we can see it graphing it. Oh, let's do the circle trace. It's a little slower, but there it is. Graph. Okay, it's not going to match in the beginning, but it does match between negative 1 and 1. If I change my window, oh, it's still thinking. Window. And I'm going to change it to negative 2 to 2, because I think that's easier to see. Maybe. Just kind of zooming in on that. Okay, now you can see at negative 1, it does approximate that. That's pretty cool. I think that's cool that you can take a rational function and you can write it as a polynomial. Because you know what? What happens? That looks like a negative 1 here. It's not. It's a 1. You guys, what happens if I take the derivative of each side? What is the derivative of the left side? It's 1 plus 2x plus 3x squared plus, then they're going to ask you for the general term, so it's n x to the n minus 1. And what's the derivative of that? If you want to make it 1 minus x to the negative 1, you may do so. It's negative 1 minus x. I'm taking the derivative of both sides because I can. So it's 1 plus 2x plus, look, see what I get here. These are families. This is negative 1 over 1 minus x squared. They might ask you for the power series for this. Do you want to take the derivatives using the Taylor polynomial, or do you want to recognize, oh, it's just the derivative of the one I know? That's what I want to do. And that's easy. Well, I've got a bunch of problems here that will do that. And then I've got some more here. Now, there are some Taylor series you just have to know. This is one of them. What if I integrated this? You guys, what's the antiderivative of 1 over 1 minus x? Now, this we need to know because, honestly, guys, this appeared last year. And the thing is, if it was in a DiffyQ and you integrated this wrong, you didn't get the integration point, and you didn't get the answer point. So you take all your time getting the answer when your integral's wrong. This is the natural log of 1 minus x, but what's missing? It's a negative 1. We're not going to make that mistake, are we? Plus c. So if I want negative log of 1 minus x, if I want that function, guess what I have to do with this power series? Take the integral. So that's so easy. That's it. I get a whole family of these things, distant relatives. So it's x plus x squared over 2 plus x cubed over 3. There's the power series for the negative log of 1 minus x. What if we had 1 over 1 minus x squared? Okay, guys? You're going to see these. You know where you're going to see them mostly will be in the multiple choice. We know this one. That's why I like the review at the end of the year, because all of a sudden things come together. Okay, guys? So what am I going to put in here for x? 1 minus. Yeah. So this is 1 plus x squared plus x to the 4th plus x to the 6th. 1 over 1 minus x squared. We just did that one. Remember where that one came from? It came from the derivative of 1 over 1 minus x. This is the derivative of 1 over 1 minus x. The negative derivative, actually. Any questions, guys? Questions? All of them. So since we're here, should we write them all down? We need to know this one. This is the geometric series. Do you guys remember what e to the x is? But you don't get a calculator on this section. Yeah, we're going to do those next. Let's get them all written down. Okay, so I kind of remember this one, and that kind of gives me e to the x. Now, do you remember the sign of x? Is it odd or even? Odd. So it's odd. So I need x minus x cubed over 3 factorial. Just want the odd powers. It also alternates in sign. Now, you can always find these again. Sometimes they're kind, and they tell you what it is. Do you know how to write an odd number? 2n plus 1? Okay, one more. You can learn the log or the tangent. Unless you guys tell me, I've not heard that there's one that you really have to know that. But these you do. I'm sorry, what? Oh, I forgot my -1. Cosine's even. So we're going to start with 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And that was easier to write. I'm not going to forget my -1 to the n. And then it's x to the 2n. Now, you can always check, do I have my -1s correct? This is n is equal to 1. Uh-oh, that's negative. So I better have what? I don't want a negative for the first one. Does n plus 1, does 2n work? No, because now I want this to be negative. So when n equals 1, then that's, no, I'm sorry, n equals 0. N equals 1, it's that. No, I don't think I want that. That's n equal to 0. That works. Now, you guys, what would e to the x squared be? Because you know what? You can't integrate e to the x squared. Those of you with a CAS calculator can try. You can't do it. So it's 1 plus x squared, x to the 4th over 2 factorial. Pardon? Yes. Well, there are some multiple choice questions that make you recognize that. Okay, guys, since you're not talking math, can you be quieter? Oh, we're almost done doing math. Won't that be nice? Okay. Now, that's not getting you into the Taylor polynomials, but that gets us into the problems. Tomorrow, we're going to do Taylor polynomials. I guess we will announce we'll have a quiz on Thursday. Couple problems. Why? Oh, okay. Well, we can make it up. Okay. Oh, don't I have 2012? Let's do 2012. So I'm going to have to add a page, and I'm going to bring up 2012. You have it. It's the first problem on your pink packet. That is the ratio test. 5 points for part A. It's easy. Don't forget it's easy.
Why don't they give us the point values on each question? Like for IB, they tell you how many points each question.
True. But what I do is, we do enough of these problems, you'll know. Do you know what I mean?
Kind of, not really though.
Yeah, the ratio test is almost always 5 points. Okay, you guys, ready? Come on. Oh. Okay, you should be doing it. If you're watching, it's not going to do any good because you won't do it. Okay. You guys, you get a point. You guys, you get a point for knowing what the ratio test is. Now, if you did not put in the absolute value, you still got the point, which I think was wrong. You don't need it, and you'll see why you don't need it. And that's, I guess, the reason why they accepted it. But I really think you should have had it there because it caused a boatload of problems. It was the algebra that caused the problem. Do I need the -1 to the n? Do I need that when I put in absolute value? No. So evidence that you know the ratio test, either what I just wrote or you put this in. So this is x to the 2, and then I'm going to put in n plus 1 there. N plus 1, and it's in the algebra. I think we have some issues over, and I'll slide this up in a moment. I just can't see it. Now, you will, on the ratio test, you'll divide by this, but that's the same as multiplying by the reciprocal. And it's a lot of bookkeeping. So if that's hard for you, then that's a problem. Yes, there is. This n becomes n plus 1 when you put it in. And that's one of the problems. I need to find my file, but a lot of kids make mistakes because they don't put the parentheses in. Well, if you don't put the parentheses in, guess what? You're not going to come up with the right answer. Okay, Trevor, what do I do next? You guys, I want you to do the problems. Nick, that's you too. No, cross multiplying. Let's simplify that. That's x to the 2n plus 2 plus 1. So it's 2n plus 3. Is everybody with me on that? Now, I like to line things up. You don't have to. And after you've done enough of these, you realize it's not that big a deal. I'm going to take this one and put it under this one because it looks like that one. X to the 2n plus 1. And this one looks like that, which is 2n plus what? Ori, what is that going to give me? 2 times 1 is 2. Eric, what's this going to give me? 2n plus 5. Okay, you guys, if you're going to chat like that, I'm going to ask you to leave. Okay? Yeah, then you can go. Okay. Now, what do you do with exponents? Now, if you don't know what to do with those, then we will do this, what I call the brute force method. We will write down what it means. It means this. It's x to the 2n times x cubed. This is x to the 2n times x to the first. Yeah, well, but if you don't do your parentheses up there, you won't get this difference of being 2. That's a problem, especially if you forgot your absolute value. And then this is 2n plus 3 over 2n plus 5, which is less than 1. Nick, what happens there to the x to the 2n's? They cancel out. What is this going to give me? X squared. Did that help to do it that way? It's bookkeeping. Keep everything lined up. Now, what's the limit of this as n goes to infinity? 1. Because it looks like 2n over 2n. Okay, absolute value is less than 1. Do I need the absolute value? No. If that had been an odd power, yes, you would need the absolute value. Well, then this is where we had the problems. Because part of it is because they didn't have the absolute value. So the students did this. And the problem is, it's not really wrong, but it's not right either. And then you know what they did? I saw this many times over. They square rooted this one, and this one, and this one. And then you get the square root of a negative 1, and we've never done any imaginary numbers. But honestly, think about it. The absolute value of x squared, or x squared, let's just go back here, x squared is less than 1. How do you solve that? Easier than that. X squared is always bigger than any negative number. That's why that's not really wrong. But it doesn't give me the end point. So, now remember, we're just going to solve. What does solve mean, Zach? Find the numbers that make the sentence true. So we pretend, and I do this in all my classes now, that this is x squared equals 1, because I can find those numbers. What numbers are they? What makes that true? Okay, guys, go. You either participate or you go. One of the two. 1, and then what's the other one? Negative 1. Now, I don't know if I get to include them or not, because those are endpoints. Okay? I don't know. But now you just have to test the regions. Eric, where are you going to test? No? I want to find numbers that make this sentence true. How about 0? Now, these are the only places that this can change from true to false. It's true for any problem you do. I don't care if it's an inequality, absolute value inequality, it always works. Forget about all those analytic methods where you put them between 1 and negative 1. It's not even right here. What if you put 0 in there? Is 0 squared less than 1? Yeah. Well, if 0 works, then everything in here works. So there is your interval. I don't know. I don't know. I have to test the endpoints. What happens? Let's put x equal to 1 into our ratio test. Let's put it into our ratio test. X equals 1, right in here. If x is equal to 1, then I'm going to get what? I'm going to get this limit. That's 1, obviously, right? This is 1, that's 1, doesn't matter what it is. And it's 2n plus 3 over 2n plus ratio test. This is my ratio test. Hey, I'm just trying to show you something here. Okay, if you try 1, the endpoint, you put it into your ratio test, what is that limit equal to? 1. Now as n goes to infinity, n goes to 0 is 3/5. Well, what happens if the limit on the ratio test is 1? We know nothing. So both endpoints, if I put them in here, both endpoints give me a limit of 1. So guess what? I got to find a better way to do it. Okay, so that's why you have to test the endpoints. Does that make sense? A little more sense now? These, if you put them into your ratio test, that's what gives you 1. And you don't know anything there. So now I've got to go back and put it into the series and find a different test. So where's my series? It's right up here. So let's do x equal to 1. Then I get the summation of negative 1 to the n. X is 1, so 1 to any power is 1 over 2n plus 3. Does that converge? Why? These were my endpoints, the 1 and negative 1, and you must test the endpoints. Now, you can't write consider the endpoints. That's not good enough. You actually have to do it. Okay, so even if you, let's say you do that wrong, because you put 1 into this series, you'll get that point for considering the endpoints. You're literally considering them. Because I'm going to put in 1 right here for x. What's 1 to the 2n plus 1 power? It's always 1, right? Does this converge? Well, we should know this. We did this yesterday. Yes. And you know what? Look at that. They even told you why it converges. It's an alternating series. Okay? Alternating series test, you don't have to say this is decreasing. You don't have to say the limit of the sequence is 0. You can just say by the alternating series test. Okay. What about x equal to negative 1? Then I'm going to, now this one's trickier. You've got this one. You've got negative 1 to the n. You've got negative 1 to the 2n plus 1 over 2n plus 3. The question is, does it alternate? Well, you can figure it out. What do you do with exponents if the bases are the same? If you have x squared times x cubed, what do you have? You have x to the 5th. So what are you going to do with these exponents? So I'm going to get what? 3n plus 1. Does that alternate? Yeah. So I'm going to find out. If n equals 0, I get negative 1 to the 1. If n equals 1, I'm going to get negative 1 to the 4th. If I get n equal to 2, I'm going to get negative 1 to the 7th. It looks like it alternates to me. If that didn't alternate, then I wouldn't include that. But it does. It converges by the alternating series test. So my interval is from negative 1 to 1. Oh, you should have seen the answers.
What if you get negative 1 to 1 and you put parentheses instead of brackets?
You'll lose points. Should we look at the points?
Will you still get points for finding it that's not?
Let's show you where you get your points.
Will you just lose points for not having any points?
Okay, here's where you get your points. 1, showing the ratio test. Okay, so that was pretty easy. All you have to do is that. Now, it worked out because it was x squared. That's why they didn't count against you on the absolute value. But if it's an odd power, they're going to count it against you. You really need the absolute value. Okay, then you find the limit of your ratio. And if you didn't get that right, some people didn't get it right, but you get a point for that. So you get 1, 1, identifies the interior. So what if you don't bother with the endpoints? You've got 3 out of 5 right there, assuming you did the algebra right. And then what they mean by consider the endpoints, by actually putting them into the actual series, even if you do it wrong, even if you have the wrong reasons here. Just the fact that you put them in, you can get 4 out of 5, even if you don't get the right interval of convergence. Does that make sense now? But you can't just say consider the endpoints. You have to put them in. Okay, so you actually have to do the work. As long as you plug them in, at least that. No. No, because that doesn't mean that you really are thinking about them. It means you just memorize the scoring rubric. Okay? Next. Now that was 5 points. I don't know. Solving this shouldn't have been that hard. But it was. And I had a devil of a time grading that because they solved that wrong. It was hard to figure out when you start giving them points, especially when they had I in the answer. That was very interesting. Okay. And then you get to B and you say, oh, it's a Maclaurin series. But that's no big deal. It's a Maclaurin series. Just means it's centered at the origin. That's all. They tell you it's an alternating series whose terms decrease. That's the conditions for the alternating series test. Okay. Well, no, we haven't even read the question. Okay, so now you better think. You got to think a little bit. It says the approximation for g of 1/2 using the first 2. Just these guys. They give you what that is. You could put 1/2 in here and figure out what it is. They didn't want you to do the arithmetic. They said it is 17 out of 120. Now, do you remember the error for the alternating series test? The Lagrange is going to be similar, and we won't do that today. But if the error is less than the total error of all these terms here, you're not going to have the exact answer to that series, but you're only going to be off by this term. All of these add up are less than that x to the, was it 5th? I don't know, I wrote on it. They're always less than that. So the fact that you consider that, don't worry about the negative sign, that's not important. So we're going to put in 1/2, so it's 1/2 to the 5th over 7. You get a point for that. The error in an alternating series test, all of these n terms add up to less than the first discarded term. Is that refreshing your memory? All of the terms that we don't use over here add up to less than the first discarded term, but it must be alternating in sign. But they told you that. So it's not Lagrange, which you don't even know about yet. Maybe I shouldn't even tell you. No, I'll probably do Lagrange this year. Okay? And then they expect you guys, you're pretty good with computers, right? What's 2 to the 5th? 32, and it's over 7. Let's say you forget how to do that. Then what would you do? You would multiply numerator and denominator by 32. So it's 1 over 7 times 32, which you know is 210 at least. How does that compare to that? No, it's smaller. That's what you want. So you say that's less than 1 over 200. I didn't leave myself any room. 2 points. And the last one's even easier. But if you don't know the alternating series estimation theorem, if you don't know that error, then you're in trouble. Now, the Lagrange is very similar. You're going to still take the first discarded term, but you're going to max it out. No, you can't use Lagrange. We don't have enough information. No, not today. No, it's the error. It's the error on a Taylor polynomial, and it has to do with the first term you don't use. This one works because it's alternating series. Okay. Now the last part is easy. Write the first 3 non-zero terms and the general term for G prime. So G is x over 3 minus x cubed over 5. I need some space. So G is, what, x? I already forgot what it was. Well, I just looked at my paper. Details. It's x over 3. I need the first 3 plus the general term. And by the way, most students did get this one right. So this was a 2-point question gotten by many students. The other place they got their points was on A because we were really kind about that absolute value. The general term here is negative 1 to the n, x to the 2n plus 1 over 2n plus 3. I want g prime. What's the derivative of x over 3? 1/3. What's the derivative of the next term? It's easy. But see, some people just quit on this because they said, I can't do this. Yes, you can. Plus 5x to the 4th. Don't do more than they ask for. If you go one step further, they will get the point docked. Never give them more than they ask for. Well, the derivative with respect to x has nothing to do with the negative 1 to the n or the 2n plus 3 because it's with respect to x. What's the derivative of that? 2n plus 1, x to the 2n. And some of you are saying it can't be that easy. Actually, I think this is one of the easiest Taylor ones. We have very high scores on this, too. I think they were averaging around 5, 6, 5, 6, 7. I don't have to look it up. I write it all down and I remember where I put it. Okay, so let's do some multiple choice. I just took the derivative. That's all it asked for. Right there. I know I'm right, so. Now, it looks a little different if you look at the scoring rubric. Whoa, wrong way. Just because they have it written differently, but it's the same. They just lined it up a little differently, but who cares? We know what we're doing, so. Okay, we don't have a lot of time left. Now, you should work through. Now, these came out of a sample test book. They're harder probably than the actual exam. So if you can do these, that's good. And you should start working on these. Tonight, we'll probably do number 11. We could, 2011 has the Lagrange error bound. But we can do 2010. But let's do the multiple choice, which if you flip over, I don't have any multiple choice on here, do I? Well, this is 2008. Okay, I will save this as a PDF. So if you want to print it out, if you want me to try and make a copy of it, I can. That's not hard. We still have 5 minutes. How about that one? Why? What kind of series is this? It's e to the x, isn't it?
Oh, wait, x. Wow.
It's 2008, number 20. I don't have it in your packets, but I could try to put it together. I probably can get it ready for tonight, if you want to do that. So this is e to the x, but what's x? Because I recognize this is the e to the x formula. That's why you have to memorize it. So the answer is 2. You have, I'll make a copy of this. I don't want all of that, though. So I'll have to figure out how to do it. I can do it. I have my prep hour. I can do it. So it's that time to go. But you do have 2010. That's 11. That was Form B. Oh, you don't have that one either, do you? Oh, that's a great one. They tell you this. Yeah, but it's the log. Use the series. Now, what's f? Oh, it's 1 plus x cubed. 1 plus x is this. What are you going to put in for x? X cubed minus x cubed over 2. Whoops, squared. So these are easy. And then you put in plus x cubed over 3. I got to do 4, right? Minus x cubed. Do I have to simplify that? No. And then you have to do the general term. X cubed to the n over n. Should we see what points that got us? And all you got is 2. You guys should be working on the next one. It's a ratio test. The only way you're going to get good at these is to do them. So for tomorrow, you should have some of these tried, and you should have specific questions. And you will have a quiz on this stuff on Thursday. Yeah, you can go. It's early, but that's okay.